All right, fan auto versus fan on. So when it says fan on, it's just a blower recirculating air through the house all the time. Keeps the air moving constantly versus auto where it only comes on when it's needed. You have a call for cooling, when you have a call for heating, then the fan comes on and recirculates air. When do you need which one? It's a loaded question, one of the big debates in the HVAC industry, and it really applies to what needs you have. For one, we have to look at what type of motor you have. If we have the older standard 3-speed permanent split capacitor motors, then that motor is going to use a decent amount of electricity when it goes. So it's moving air, it's using a decent amount of pulling, a decent amount of amps, a lot of wattage going through there. Some of the new motors are ECM, X13, variable speed, constant velocity, or constant torque motors. These motors are a lot more energy efficient. It's going to use a lot less energy to move that same amount of air. And when you leave the fan on, it runs the fan constantly at a lower speed. So it's a lot more energy efficient to do that. So with the new ECM and variable speed motors, you can keep the air moving for a very small amount. It's like running a 60-watt light bulb, just an approximation. So having that in residential, having the fan moving, the benefit to that is you're going to have warm spots that build up in your house. Maybe this section of the room outside the wall will have more heat and be warmer than the section over there. So the idea is if you have air moving constantly, you can keep that room a much more comfortable temperature, which is what a ceiling fan does. It helps keep that room, the air moving, and having movement over your body makes you feel cooler. Speeds up evaporation on your skin. It keeps the cooler air moving across your body, so you always feel cool with air movements. It's the best to have this localized with a local fan. Tower fan, ceiling fan, keeping the air moving across you can definitely make you feel comfortable and save you a lot of electricity. Now, fan on all the time versus auto. Let's talk about a condition. Let's say we're in a humid climate like Florida. The air conditioner has to do a few things first. It has to cool the air and dehumidify. Before we had Willis Carrier, we cooled with ice and fans. But Willis Carrier invented AC to not only cool the air, but to dehumidify it. So we pull moisture out. So when we're pulling moisture out of the air, the water that's in vapor form has to condensate onto the coil, and it goes from a vapor form to droplets of water. These droplets of water collect on the fins of this evaporator coil. They run that into a drain pan, and that drain pan then drains that H2O physically out of the house. It physically pulls moisture out of the air and drains that moisture outside. By doing that, by pulling moisture out of the air, we drop the humidity of the air, which makes it more comfortable. The higher the humidity, the warmer it feels because we have less evaporation going on. So the drier the air, the cooler it feels, the more comfortable it generally is. So by dehumidifying the air, pulling the moisture out, all that water runs on this coil into this drain pan and runs out. If we live in a humid climate and we leave this fan on all the time, the AC shuts off, so the temperature of this coil goes up, and if we continue to move air across it, I take this moisture that I paid money to pull out of the air that's still there, this moisture will then evaporate back into the air. And as it evaporates and goes back into the air, the coil dries out, and we're putting moisture back into the air. So as that moisture goes back into the air becomes more humid, we lost a decent amount of efficiency. So if we have a humid climate, we for sure want this fan to cycle only when the unit's running. So now when the unit's running, we're dehumidifying, that water collects and runs outside. When the unit cycles off, the fan also shuts off, so that water that we've paid money to dehumidify, to condense out of the air, that water stays in this evaporator coil. And some of it evaporates just in this area, but it stays right there. The next cooling cycle comes on, we drop the temperature of the evaporator, we start pulling moisture out of the air, fan comes on and move that cool air back into the house. So in a humid climate, you for sure want to have that fan to be where it runs as least as possible so that we dehumidify, and also at a lower speed. This does not include variable refrigerant flow units. Some of the newer systems, Daikin, also Mitsubishi have designed systems that are made to run non-stop. They control the capacity of the unit to constantly cool the house. We're not comparing to that at all. We're just talking about a standard AC with the blower. So in a humid climate, you want to cycle that fan on and off. On a dry climate, leaving that fan running is a good idea because it keeps the air moving, right? Sounds good. But it really depends on also now your ductwork. So let's think about Las Vegas where it's very dry. There's no dehumidification we have to worry about because it's so dry here anyways. The ductwork, though, around Las Vegas and the unit itself is up in the attic. So let's say it's 100 degrees outside. You know, you're looking at about 140, maybe 150 in the attic. Let's say 140 degrees in the attic, which is significantly hot. Then the air in your house, let's say you have your temperature air at 75 degrees. So the return air that's going into the unit, 75 degrees, it's 140 degree air that's going in and heating up that air, just being in the attic alone. So as we run that fan, it's only 2 inches of insulation separating that 75 degree air from this 140 degree air. So the more air I move through that unit, the more heat I'm picking up. But then let's think about the air coming out in the ductwork side. Let's say the temperature of the air here is, let's say, 50 degrees Fahrenheit. So the temperature of the air is 50 degrees, the attic's 140. Now there's a big temperature difference. So the heat here from the attic is going into that ductwork. So again, we're losing efficiency by having the ducts in the attic. We're actually reheating that ductwork up. So there's a certain amount of loss that's going to happen. Now if I leave that fan in the on position and I'm moving air through this unit, through the attic all the time, non-stop, keeping that air moving through that unit, then there's more air touching more of that hotter temperature attic all the time. So one of the theories is by leaving that fan in the on position, you're actually heating the air in the house up. Plus also if you look at the heat of the motor. The other idea is that if we cycle this fan off when not being used, the ductwork will heat up, but when the system comes back on, it cools it off quickly and it cycles and keeps the house more comfortable. Generally, they say not to have the fan in the on position in residential in the attics because of that extra heat process, but there's a huge debate on that. My feeling is to have it set on auto. In a humid climate, if your ductwork's in the attic, also have it set for auto. On commercial buildings, you have a different rule set. Commercial systems have multiple compressors a lot of times. We have different built motors. Commercial buildings have a different design. So commercial buildings, I prefer to leave that unit running all the time. If that motor stays running, there's less wear and tear in the belts and the bearings, and it's better to keep that big unit running constantly than having it cycle on and off. A residential unit, I find that it's better to really have it cycle on and off as we need, unless you end up with the new variable refrigerant flow systems. And these systems are going to run non-stop, but not just a fan, the whole AC system. If you look over here, we have a ductless system. And a lot of these ductless systems now are using variable refrigerant flow technology. So it's not just that the fan's running all the time non-stop. The refrigerant that's running through the evaporator coil here is running at the same time. So we're constantly dehumidifying, constantly cooling the air, and there's no ductwork. So we don't have to worry about the attics getting hot at all. So there's an incredible energy efficiency in here. One other thing I forgot to mention was loss. Let's say we have leaking ductwork. So if I have the air that's leaking outside the duct system, that's an immediate energy loss directly. But as I take air out of this room, then I have to worry about depressurizing the house. So the pressure of the air outside is greater than the pressure inside because the fan's literally pushing some of the air out of the house into the attic. Well, then the pressure outside has to bring air from outside back in. As we're bringing air from outside in, we're also bringing in more polluted air and also possibly, and also we have to deal with, we're bringing 100-degree air into this house, and that's going to be an issue. Through the doors, the windows, cracks in the ceiling, through plug outlets, anywhere it can pull air in. So we want to make sure those ducts are sealed, and ideally spending as least amount of time that air touching that hot attic air as possible, which is why attic ventilation also plays an important part of that as well. But we can keep going on this all day long. Simply on residential, it's probably better to have the fan on auto. For most typical systems you see, there's always exceptions to that rule, and it depends on what part of the country you live at. If you're in the Midwest, where you have ductwork in the basement, summertime, low humidity, then by all means, leave that fan in on position. It's going to help make it more comfortable, especially with an ECM or an X13 motor. But if you live in a humid climate, for sure you want it on automatic. And if you live in a climate like this, where your ducts are in the attic, which isn't the ideal place, you also want it for automatic. All right, if you have any questions, please send me an email. Thank you.